Hi everyone. Welcome to the Emerging Areas Knowledge Sharing Session number 13. I'm Darren Young. I'm your host. I'm part of the team here by working with Baringa Partners. The theme today is on coal decarbonization pathways in Asia and the Pacific, integrating cold and cryogenic storage, logistics innovation, and clean cooling technologies. With us today, we have three individuals who you'll hear from in a moment. We have Professor Alessandro Romagnoli, we have Eric Colkin, and we have Arvind Chandraka. But before we start, I'd like to hand it over to Cindy Tianko to say some opening remarks before we get into the presentations. Cindy?
Let me start again. So good morning, good afternoon, good evening, everyone, wherever you are today. Thank you for joining us. As countries across Asia and the Pacific continue their journey toward low carbon, resilient, and inclusive energy systems, we know that cooling is becoming one of the fastest growing energy needs across our economies. And while I am not a technical expert in cold or cryogenic technologies, I'm very excited to learn alongside all of you today. What makes this session particularly interesting is that it brings together solutions many of us may not be fully aware with or familiar with, innovative technologies that capture and store cold energy, improve cooling efficiency, decarbonize cold chain logistics, and even provide long-duration energy storage. So these innovations may sound highly specialized, but their applications are incredibly broad, from food security and pharmaceuticals to data centers, manufacturing, and grid reliability. So today we have an excellent panel of speakers from NTU, Sumitomo, and Carnell Fleet who will help us understand these emerging opportunities in a clear and accessible way. I encourage everyone to take this chance to ask questions, share your experiences, and explore where these solutions might intersect with your own work. I would also like to thank our moderator, Darren from Baringa, for guiding today's discussion and helping us unpack these complex but exciting topics. One of the strengths of gatherings like this is the opportunity to build new connections between policymakers, ADB project teams, private sector innovators, and development partners. If something sparks your interest or resonates with the challenges you see on the ground, please reach out. Collaboration often begins with a simple question or conversation. Thank you once again for being here. I'm very much looking forward to learning from our experts, and I hope this session inspires new ideas, partnerships, and pathways for cleaner and more efficient cooling across the region. So with that, let us begin our webinar. Over to you, Dan.
Great. Thanks, Cindy. And yes, as mentioned by Cindy, there is such a change going on in Asia and Asia Pacific and the emerging islands that we all support. And the challenge to decarbonize is a big one. So with us today, we've got three presentations, short ones, 10 minutes each. First, we'll be hearing from Professor Alessandro from Nanyang Technology University or NTU. He's going to talk about cold thermal energy storage. And so perhaps I'll hand it to you, Alessandro, to share some slides and share a little bit about the innovations that you're seeing. And for the audience, if you think about some questions, we can ask those at the end. But what I will do is I'll open up for questions at the end as well. So, Alessandro, over to you.
Okay, so let me share screen. Wait. Can you see my screen?
Yes, we can.
Right. Okay. So good afternoon. Happy to be here for this webinar on cooling and decarbonization in cold and refrigeration sector. So today would like to basically introduce you to some work that we have been doing around LNG, liquefied natural gas, and its utilization. So just to give you a bit of a perspective, and probably the numbers here are not up to date, but as you know, natural gas is being shipped worldwide in liquid form. That's why we call it a liquid LNG, liquefied natural gas. And here there is a Singapore perspective on how much of this worldwide LNG gets into Singapore. But in actual fact, what is this LNG is going to be used for when it reaches the terminal or the country? is mainly to generate power, because gas can be, the liquefied natural gas can be regasified and used for power generation. But then there is a catch around LNG, because in order to transport natural gas in liquid form, right, as liquefied natural gas, we need to basically bring down its temperature at minus 162 degrees Celsius. So you see this tanker or also terminal, they are basically storing gas in liquid form at such a low temperature, at minus 161 degrees Celsius. And then during the regasification utilization, there is a process in which the temperature changes back from minus 160 all the way down to ambient temperature. So there is a huge temperature difference that indeed is what we call is a source of energy, cold energy, cooling energy, that at the moment is not being utilized. So just to give you a perspective, in fact, a 250,000 meter cube LNG tanker could potentially produce, serve in terms of cooling available generated from the regasification, or it could serve 15 large supermarkets for 1 year. And as you can imagine, this means that they're going to bring a lot of savings in terms of electricity and CO2 footprint. So when it comes to natural gas and LNG, again, I mean, this is just to give you a perspective. Out of the energy content in the natural gas, 98% is chemical energy, and the remainder 2% is cold energy. So today we are focusing on this remainder 2% that, although it seems small, it still carries quite a bit of value when it comes to decarbonization. So what the natural gas is being used for? Power generation, right? And here you can see some acronyms to highlight which are the technologies which are being used for power generation. Then you could use the cold energy for cooling application. And now, as you might imagine, there is a number of different applications that you can explore with such a large temperature difference. And then there are sort of in between or hybrid use case in which the coal can be used to sustain the power generation. So this slide gives you more broadly the sort of use case for cold energy at different temperature level, right? So if you here you see the different delta T temperature level, right? Here you can see which are the application or use case that demand cold at the given temperature. And as you can see, the amount of cold available from the LNG, right, during the regasification, it sits well below, right, the application, which means theoretically LNG coal could serve the majority of cooling and refrigeration of deep cold sector. So what is the point now? I mean, the LNG reaches terminals, and normally the regasification is being done in the proximity of the terminal, which means if you want to tap into cold energy from regasification, very much so, we might be in a condition in which we either have a on-site user of the cold energy or users nearby, which means users within a distance which justify to extract cold from the terminal and move it elsewhere. And here you can see a number of different applications, right, where this code could be used on site or nearby. But now there is an angle that, and again, I mean, the slides here, I'm not going to go through the details, but when it comes to utilization of LNG cold energy, we have done quite a bit of work in evaluating all the potential utilization and integration with power plants, power generation, and heat and cold integration, trying to evaluate which is the improvement in terms of overall efficiency and carbon footprint. But one angle that I want to bring in today is the case in which the user of the coal is no longer in the proximity of the terminal, but is rather sits at the distance of the terminal. And the reason why I'm bringing this into the picture is because many times the terminals are either put in very remote areas. Co-location of facilities, it might not be an option. Co-location of facilities nearby LNG terminals might not be an option. And also, as you can imagine, lay down infrastructure for cold energy utilization, it might not be always as straightforward. So the angle we are coming from in some of the work that we have been doing in NTU is that of saying, if the user is at a distance, is there a mean to store the coal and to transport the coal, dispatch the coal wherever there is a demand for it? right? So that's basically the angle we are coming from. And here, in a way, it shows you the scenario where the terminal, there is a regasification of the LNG. We can somehow store cold, right, and move it to the end users wherever there is a demand for it. So the question is how we're going to store this cold and how are we going to mobilize it. So now I need to switch into another. Can you see my slides, the new slides, or not?
Yes. Yes, we
Can
need
you?
to over. Yes, we can. Coal battery.
You said a cold battery, yes. So I mean, now I'm jumping into more into the technology development that we have been doing in NTU. Again, here is to reiterate what I just said, right? There is a cold supply, which is either in the wrong place where the cold demand is, or it happens during the wrong time where the regasification occurs. The cold energy is there, but there is no actual demand during that time of the day to utilize that cold. So we sort of developed this concept called technology called cold battery, cold energy batteries. And the way it works very much like an electrochemical storage, lithium ion, whatever, right? There is a phase in which it needs to be charged, right? We store the energy, and then there is a release of the energy. So here you can see in this slide is showing you some of the work that we have been doing in my lab to test solution to store cold at a very deep temperature, right? So this is a packed bed system. And the idea is to indeed store cold from the terminal and move it to the end user. So where does our battery stand in terms of other form of cold energy storage? Here there is a competitive analysis with chill water storage, ice storage, and other materials that are currently being used for storing cold. Where we are coming from the NTU side, we actually picked and merged all the best features of all these more established existing technologies, which means we have been working on developing materials which are sustainable, that enable to store coal for over a long period of time. They are low cost. They actually can cycle over thousands of times. And then last but not least, the materials that we have developed can span over a wide range of applications, meaning that we have materials that can store coal at temperatures that go from 0 degrees Celsius all the way down to minus 16 degrees Celsius. So yeah, this is just to mention how the battery works and the concept that I just shared, mobilization of the coal. And we did some study trying to evaluate where this battery could fit in, what kind of benefit could bring to the end user, and what it could be the benefit, and what it could be actually the economic incentive. So if you consider the utilization of this free cold coming from LNG terminals, this is definitely comes as a premium source of cold that could be help to offset the electricity bill by more than 50% to most of the end user working in the cooling and refrigeration supply chain. And the cold battery, it also fits pretty well in those countries or markets in which price arbitrage or between day and night is spread enough to justify the charging of the battery at night and release of the cold during daytime. So the battery in a way can also serve as a sort of peak load shifting between day and night for some of the end users in certain specific market, should not be the cold energy from LNG or be made available. And when we try to validate the potential use case for these cold batteries, here we talked to a number of different potential users in China, in Malaysia, in New Zealand, looking at different kind of markets. Each market, of course, carries a different temperature range. But what I can say that for most of the end user we talked to, we could see a merit in deployed cold thermal energy storage as a mean to buffer and reduce the electricity bill to produce coal for the process and applications. Where are we with this battery development technology? In fact, we demonstrated a prototype during the last Singapore International Energy Week. Here you can see some work that we have done with the Singapore liquefied natural gas, SLNG, which is basically the terminal in Singapore that stores LNG. And here is a use case where we were basically demonstrating the ability to store coal from the terminal, put it inside a box that you can see here in black, and use it to basically provide cooling and refrigeration for an aircon and also for a refrigerator system for at around -10 degrees Celsius. And here you can see some of the pictures where we had also the minister of from NTI visiting our booth. So yeah, so that's where we are. That's what we have done, and yeah, happy to take the Q&A session. Thank you.
Thanks, Alessandro. It's fascinating. So, I mean, what you're basically saying is you're capturing the cold from the cold LNG and then using that and transporting it as a battery to locations that now could use that. Fascinating technology. Perhaps we can talk a little bit more about that later on
Yeah,
when we look at sort of on the panel for the team. But thank you for that. Really, really interesting stuff, and congratulations on all that research and hard work that you put into. I'm sure it's really pioneering stuff.
yeah. Thank
So next up, we have Eric Colkin. So he's the Director of Sales and Commercial at Sumitomo. Um, Eric is going to talk about LAES, which is basically liquid air storage solutions. Tell us about, over to you, Eric, to tell us a bit more about that.
All right, thank you so much. Appreciate it. And thank you, Alessandro. It's interesting to hear about your technology and actually set some ground work for some of the things we're going to talk about now. So I appreciate it. So yeah, my name is Eric Colkin, Director of Sales and Commercial at Sumitomo SHIFW, or SFW. It's a little bit easier to say. We are a provider of decarbonization solutions, whether it be carbon neutral or carbon negative energy generation, carbon capture solutions, gasification, or long duration energy storage, which will be the subject that I'll be talking about today. Our long duration energy storage technology is liquefied energy air storage, which is built around the Claude process that is used in the air separation and LNG industries. Essentially, we use excess renewables to run compressors to compress ambient air, recovering the heat of compression and storing that, then liquefying the air to store in pressure vessels. That way we have a high energy density and locational flexibility. Then when the power is needed to be dispatched back to the grid, we vaporize the air, recovering the cold energy of vaporization, and then superheat the air and then run it through what is essentially a steam turbine. So built on a lot of well-established technologies throughout industry, whether it be in the air separation, LNG, or just general traditional power generation, to allow for hundreds of megawatts of capacity at 8+ hours of storage duration. So why thermomechanical energy storage? Well, the future distributed grid has a handful of challenges that come from, again, the shift from large synchronous generation to increasingly distributed and non-dispatchable generation. You have an increased amount of inverters that result in loss of inertia, transient voltage issues, and short circuit power. Obviously, supply and demand mismatch. The sun shines when it shines, the wind blows when it blows, and you don't have control over those things. And that can either lead to oversupply, which leads to curtailment, or undersupply in periods of time when that generation is not available. You also have transmission challenges as the load or the generation sources shift away from where the load sources are. And you can see that this is not just theoretical, that you're seeing billions of euros, dollars, pounds in costs around the globe resulting from trying to address these issues. So we see our LAS solution as kind of addressing all three of those problems all at the same time. So we are based around synchronous generation and synchronous charging machinery in our system that supports the grid stability through inertia, for helping with MVAR and short circuit power, obviously provide the storage to allow for the shifting and security of power when you need it. And then we are locationally flexible. We have a comparatively small footprint in line with what you would see for lithium-ion batteries on an energy density per square meter basis. And again, we have no geographical constraints so that we can be put where we need to be. This allows us to, the combination of renewables plus an LAS system to allow for dispatchable generation for bulk energy shifting, grid stability in a flexible, compact footprint with 30 years of life. And again, able to be implemented where you need it to best serve the grid. And it's not just for the purposes of serving the grid, but also values in co-location. So as Sandra was saying earlier, there is value in the waste coal that comes from LNG import. So our process can be integrated within other industrial processes to either provide or consume heat at various different grades to co-located processes. But maybe most importantly for our discussion today, we can also import waste coal from other industrial processes, such as an LNG import terminal. And we are in the process of putting that into practice right now. Our 20 megawatt hour demonstration scale commercial plant built by our parent company, Sumitomo Heavy Industries, in a partnership with the Hiroshima Gas Company in Hiroshima, Japan, at the Hatsukaishi LNG import plant is co-located there, and we essentially provide waste heat from our process to support the regasification of their import LNG that provides waste coal to our process, improving the efficiencies of both systems and allowing for us to serve the grid in the area. This plant, again, is in the late stage commissioning, should be reaching commercial operation within the next month. We have been synchronized with the grid for about a month now here, so this is an exciting development for us, and a sign of things to come for the rollout of this technology around the world. So I appreciate the time and looking forward to the rest of the discussion here on these cold technologies.
Thanks for that, Eric, and sharing that. Really interesting around the circular nature of how cooling and using that cold and using the heat back into the system is really interesting. I'd like to pick up a little bit more in terms of overall a bit later around application that you're seeing across Asia Pacific and modularity and those type of things, which kind of in my head. But before that, we'll just hand over to our last presenter, Arvind. Arvind, I would sort of summarize your company as like cold chain as a service or something along those lines. And I could imagine that being very interesting for very dispersed markets and islands and those type of things. But maybe I'll let you talk a little bit more about share what you've been doing and seeing in your new technology. Over to you, Arvind.
Absolutely. Can you guys hear me?
Loud and clear.
Excellent. So yes, like you said it, Darren. So we're really focused on the cold chain at the end of the day. Just obviously a fancy word for temperature controlled supply chain. For us, we're focused on a variety of goods, whether it's food or pharma or everything in between. But really, the focus is on perishable goods at the end of the day. So to kind of jump right into it. Really, one of the ways we've structured what we're trying to solve, especially in Asia, is that we understand that loss rates are extremely high for a lot of these perishable goods that are obviously key for a lot of the growing economies that we're focused on, again, primarily in Southeast Asia. We found that those global loss rates are around 24%, but in, again, the geographies that we're looking at, it can grow as high as even 40, even 50%. And so at the end of the day, this is product attrition that's happening on a massive scale that, isn't really being tackled at the end of the day. When we look at this in detail, there's really two pieces that are related to this. So of course, the lack of cold chain implementation and the improper implementation of it is one piece of it, and then human error is basically another piece. And so it's really our goal to tackle both these problems in a way with certain kinds of technologies that can help essentially bring this number down as close to zero as possible. And if we really look at this in detail, the driving force behind this at the end of the day, and this would be the case across all of APAC in general, is really that of cost. Implementing the simplest means of cold chain, even today, is extremely expensive. You could see it in, a player as big as, giant multinational F&B companies that are operating across these geographies, and you could see it as small as scale of, a mom and pop shop, doing these kinds of deliveries basically to more local environments. And what we're really trying to do is, once we understood that, this cost parameter is the biggest problem, how do we devise solutions around it that not only make sense from a commercial landscape, but actually ensure the protection of these different kinds of goods that are important for the growth of these economies. So I'll transition into talking about us really quick. So we're Carno Fleet, and we're a company that essentially focuses on this kind of problem. We're essentially an IoT company, so we build both hardware and software targeted towards solving these problems, and we're located in multiple geographies at this moment, all really focused on trying to solve this problem within the cold chain. And so high level, what we really do is we design these different kinds of cold chain solutions that are plug and play in nature. So they're instant, safe, and affordable with really quick installation times. And ultimately, one of the key ways that we found that we would be able to tackle this problem is by using actually solid state thermoelectric heat pumps. Not only, are they extremely clean with, lower carbon footprints at the end of the day, but they would actually be critical for a lot of the first, middle, and last mile deliveries that, we primarily are targeting at the end of the day. And obviously, one of the big things about what we do is creating cuts across all the kind of expenses that go into building your cold chain, whether it's the CapEx, OpEx, or entirely looking at the TCO angle. And of course, there is a really good competitive advantage to trying to get, these products installed and moving as quick as possible, because ultimately it means that these businesses can benefit from all those capabilities. And of course, the end consumers would also benefit from all these capabilities. And so, like I was mentioning, one of the key ways we look at this technology is really on the thermoelectric side. We've created, obviously thermoelectric cooling has been around for a while, but what our angle has been is, if you think about cost as sort of the primary optimizing factor, then you start realizing that a lot of the traditional compressor-based cooling systems that are used in a lot of cold chain transport is kind of overspec'd at certain levels. Now, it's of course very useful in large scale storage scenarios like warehousing, but if you're looking at, 1 to 3.5 ton trucks, which are some of the most common ways of not only doing first, middle, and last mile deliveries, you'll see that it is overspec'd. And, essentially what we've done to angle it is really build a thermoelectric heat pump that is less expensive, and that actually creates solutions that are much cheaper in nature without also having to have as much insulation at the end of the day. Of course, this is paired in with a lot of the kind of software that we create that helps with the measurement of what's going on in the cold chain and actually understanding what's going on throughout the entire life cycle of the cold chain, which is pretty unprecedented at the moment. And so, we obviously have done this with a pretty sizable team looking at both hardware and software, amongst the various industries. And yeah, essentially, the three ways that we're able to kind of tackle this problem is really trying to maximize the heat transfer, using these thermoelectric cooling, the thermoelectric modules, essentially, trying to minimize the heat loss as much as possible. And then, of course, actually having precision over the temperature control. One of the ways we do that is obviously by controlling a lot of how much energy that we use at the end of the day. which is critical, of course, in a lot of these thermoelectric systems, because the first question that usually comes up is, aren't you actually expending a lot more energy? But the way we're going about setting up essentially processes and things like that is it would end up taking up less energy. And of course, there would be benefits on that lens from not only using less energy at the end of the day compared to alternative either compressor-based solutions or passive solutions, but we're actually able to toggle the problem of loss, which has a bigger decarbonization angle. This is just a few highlights. I don't want to go too focused on it, but it kind of shows how we're able to actually deploy a lot faster, whether it be from more of a work operations kind of angle or a human labor kind of angle, which are both important to the overall kind of go-to-market. But then at the end of the day, not only is time saved, but we're actually able to save a lot of costs for our customer as well, where the alternatives end up having them to use a lot of upfront costs in order to set up, either retrofitting of their entire fleets or purchasing of brand new equipment that is just frankly too expensive, or the additional OpExes of now having to maintain this new technology, which frankly tends to have way more parts and components and needs additional refrigerants and things like that. So these are just a few kind of views of some of the customers that have used it over time. I mean, we do things from large scale containers, that are more using kind of like a hybrid thermoelectric heat pump that we've built, to more hub and spoke models that you see here with racked units that we have, to basically multimodal deliveries where we can have different kinds of temperature ranges for different kinds of goods as well. All of this is to say basically like, what's the point, right? So it's great. I mean, we're able to reduce costs. We're able to move forward a lot of the players that exist in this arena. But at the same time, being able to actually have reductions in, I guess, overall carbon emissions from cradle to grave is extremely important. And we do achieve that with the product. But more so focusing on that angle in addition to, the prevention of loss allows us to get a much larger, basically, allows us to tackle essentially a much larger decarbonization angle at the end of the day. And that's where we actually see some of the greatest emissions reductions at the end of the day. And I think some of these points kind of show the scale that we can really help the market if we were to deploy in mass scale. So yeah, I just want to end it there, and just basically show a different angle of how using a different kind of technology entirely on the ground is seen more at like a commercial angle essentially. So yeah, thanks.
Great, thank you, Ivan, for sharing. At this point, I'd just like to open up for questions. So feel free to either put a chat in the chat box, and or if able to perhaps just raise your hand or chip in with a question. But I'll kick it off with this team here. So it's interesting listening to all of you. Some are kind of more small modular, some are larger solutions in the market. Perhaps I'll just go back around to Alessandro and I'll ask each of you the same question. But if you were to look at your current solution that you've got, and the innovation that you're bringing, where are you seeing the applications in the market across, say, the Asia Pacific landscape? So first of all, start off with that question, and how are you seeing that go to market with your technology? So maybe I'll start with you, Alessandro.
Yeah, no, thanks for the question. I mean, just maybe a few words before I answer to your question. I mean, the concept that I showed you is at the moment, and I would say the idea is not to mobilize boxes or batteries from the terminal to the end user, but the idea is to actually to have a fixed battery to the end user size and somehow mobilize the cold from the terminal to the end user. So, I mean, just in case, otherwise, it's not very easy to think to mobilize this batteries, but there is ways to mobilize the coal. So that's point number one. And I would say that was not disclosed as part of the discussion because it's under some sort of IP filing as we speak. So we are not in a position to fully disclose. And then when it comes to where we see the battery to be applied to, I mean, the battery in itself can operate pretty much over a very broad temperature range. But the best use case that we see is in that sort of freezing refrigeration space where you need to heat those temperature between -10, -20 degrees Celsius, or even slightly lower in certain cases. And that is where the coefficient of performance, the performance of current chillers starts to drop quite drastically. And that is where the electricity cost penalty associated to generate that cold is actually can be quite hefty on the end user side. So the battery in itself can help to sort of offset that penalty due to the fact of generating that deep cold. And some of the work that we have been doing is for with the refrigerator warehouse shows quite compelling numbers when it comes to for this battery to either be assisting the existing chiller system, or for the battery to be able to fully take over the cooling and refrigeration of the warehouse, for instance, meaning that we are sort of getting rid of the chiller altogether. And last but not least, you need to think that these batteries are solid state technology, likewise thermoelectric. There is no moving parts. It's just the coal happens by means of some phase change process within the materials. But that is where, if you look at the lifespan of this battery, it is extremely long and they're extremely robust and do not degrade likewise other form of energy storage.
Really interesting. And if I maybe ask maybe a silly question, but like, is it primarily linked to when you mentioned? So I'm actually at EDB today in Singapore, so the government here, and we were talking about biomethane, which also requires cooling and liquefaction. Does your solution primarily link back to where there is a very, very cold liquefaction source, or can it be applied in other areas? Yeah, what are the other scope of application?
Yeah, no, and in fact, I mean, the extreme deep cold, actually, we will say is not, we cannot make use entirely of that deep cold. And that is where my colleagues, Sumitomo Liquid Air Energy Storage, will come in, right? When it comes to these deep cold applications, such as low cryogenic temperatures, coupling that cold energy extraction with a like LAES system, from an energy efficiency standpoint, it makes much more sense. For what it concerns the battery can work pretty much at any temperature, right? So in order to be charged, it can work with different streams of cold energy available. It could come from, now there is a lot of hype around ammonia. Ammonia is stored at -32 degrees Celsius. So there is room actually to tap some of that cold from ammonia for other processes that have cold energy as a byproduct. But like I said, the battery can also be co-located in the premises of a facility and can be charged during nighttime, for instance, taking advantage of the price arbitrage to being discharged during daytime when there is the electricity price is larger. So the battery can serve different use case, different business models. What we are trying to sell here is that extra degree of freedom that might come from having thermal energy storage sitting on site, and to take advantage of whatever is going to be the best scenario depending on the region, the cost, and the context, and the market applications.
Interesting. So it's quite a broad application of the cold element. I know that in the market, and many of us would be appreciative that coal assets are now being co-fired with ammonia. So there's a lot of conversation around basically moving ammonia around, and to your point is perhaps that also is an add-on benefit when you're storing ammonia for transition assets like for coal plants into co-firing with ammonia. There are potential solutions there, so that would play into the market like Philippines, but also all markets around the world that are traditionally using that. Really interesting, Alessandro. Maybe I'll pivot a little bit to Eric in terms of your liquid air solution. Where do you see the applications today? Like if you were to sort of think about scaling what you're seeing from Japan and across the board, like, across Asia, like where would you start?
Right. I think there's three kind of driving factors that we see across Asia when it comes to like an adoption of a technology like liquid air energy storage. The first being obviously adoption of renewable generation to allow the more renewables you need, the more storage you need, the more ability you need to be able to shift the energy from when it's generated to when it's dispatched. That is a secondary component to that. The more renewables you need, the more support you need for grid stability that comes from, again, the synchronous generation that we're talking about here. Obviously, across Asia, there are a variety of different LNG import terminals that are kind of an ideal co-location for us. We can use the waste cold and provide a service to the terminal while also providing an efficiency benefit to us. It's a win across the board. And conceptually, if there is also a co-located combined cycle plant or whatever, fired on whatever, if there's excess heat generated in that system, we also have efficiencies in utilizing that in our system. I think the last case we see as valuable is essentially, islanded grids on actual islands that essentially have a different cost structure when it comes to their fuel source and a more driving incentive to decarbonize, and a grid that will quickly shift from a traditional generation to a distributed generation that will need the stability support because there are not other rotating masses on the system to provide the stability there. So again, those are really interesting opportunities for us in the Asian market. So.
And if I were to sort of narrow down into 2 points you raised, one around sort of stability factor and two around sort of co-locating, if you were to sort of highlight from your bird's eye view, where are the countries that are probably right for co-location, and then also in terms of stability, where do you see the opportunity? Is it like solar, or what other parts that you're seeing around the intermittency challenges you raised?
So I think that I think an obvious answer is Singapore with a high amount of import LNG coming in. There's a reasonable interest there. We are also seeing some interest in Thailand along the same lines. On the stability side, I think it is, again, that's more of a kind of, we see where things are going on the adoption. It can be solar, it can be wind. It's just we generally say once you get to 40%, you start seeing a real need for long duration and a real need for the stability services that can come along with a mechanical energy storage system.
Got you. Yeah, I'd imagine that as countries transition and get more invested in these longer term assets, then you're going to start to see these kind of bigger, like co-location solutions, or I need that intermittency issue because I'm relying more on say renewable energy like solar and stuff for the grid. Really interesting stuff. So it's interesting to see the sequence. I'd like to come back to you, Arvind. I mean, your solution feels a little bit more sort of, we can get out to all parts of the world, or all parts of tier 2, 3 country cities type of conversation. But maybe you could share a bit more, like where do you see near-term opportunities? How would we be using your technology across which markets?
Yeah, I mean, there's a very particular reason why we started in Asia compared to other regions, and we plan to start here and expand outwards, right? So I hate to say it like this, but a lot of the Asian countries have sort of the perfect set of problems for something like our solution to exist. So if you look at it from a heat and humidity sense, obviously a lot of the countries here fit right into that ballpark. There's usually extremely high traffic in a lot of these countries. Not a lot of investment into cold storage, frankly, as much as we wanted to see, especially in the warehousing space. And then less capital in general than compared to, say, like places in Europe and the UK, or sorry, EU. And then even broader, you don't have a lot of land to begin with. And some of the Southeast Asian countries, especially, we're looking at where it's very densely set up. So what happens is basically you have situations where, these kind of 3PLs or logistics providers in general are taking goods from, if they're lucky, cold storage warehouse or something to their kind of spoke location or delivery location as fast as possible with or without cold chain. And then lo and behold, we see these lost numbers that I was quoting earlier. So, and it's not that much of a surprise at the end of the day. So I think first and foremost, if one of the big reasons that's happening is because of that cost. So I think getting started with any player in the first, middle, and last mile is important. And I would say it's quite diverse is the thing. So the approach is not so much, oh, just try to target 3PLs at the end of the day. It's more about trying to assess all the different kinds of players that would exist within any kind of cold chain and targeting them. It could be F&B companies that run their entire supply chain. It could be pharma distributors. It could be those pure play 3PLs, or even e-commerce platform providers that may not necessarily do logistics themselves, but have tons of influence over how the gig workers would perform in their gig economies essentially. So our goal is to make it as successful as possible, which is despite being independent solutions, tailoring them best without having to spend additional capex on our side in order to create actually an end-to-end cold chain that users would want, rather than a one-size-fits-all kind of solution where we've seen that kind of system exist with a lot of the companies that we've been seeing coming out of Japan and China for many years at this point. So
Yeah.
that tilt towards both customizable and playing to the Asia Pacific market is important for us.
Yeah, it's interesting, and you've kind of there's a question which I'll go back and ask all, but you've kind of answered that a little bit, Arvind, in terms of the barriers for adoption, right? And perhaps Eric and Alessandra also answer that. But pitch, I mean, coming back to how do we adopt this technology? I mean, technology is great, and the challenge is how do we get people to use it? What are the barriers that you see, Eric, from your point of view? And then I'd like to come back around and sort of then put it from a perspective of, well, if I'm ADB or I'm a government agency, how would I help accelerate this? So maybe I'll first of all go, Eric, what are the barriers? I mean, perhaps it is big infrastructure projects, but like, what would you summarize as the barriers for adoption for your technology?
Maybe I'd say there's twofold ways you can do this. I think that so we talk about the grid stability a lot, and so traditionally that grid stability is provided just as a part of the generation. So if you have a coal-fired power plant and it has a large generator associated with it, the stability service comes along with the generation. But when you go to solar and wind, that stability is no longer there, and so there hasn't been recognition of the value that's provided by that. It's been inherently necessary, but hasn't been recognized in most markets with compensation for those services provided. So I think adoption of the value of those services is an important thing, and then recognition of the need for long duration energy storage and procurements that go along those lines. We're seeing those pop up across several markets around the world. I think Australia is leading the way on that. I think we're seeing some of that in North America as well. But those targeted procurements that recognize the need for the long duration from the ISOs, from the utilities, I think that's an important, or the TSOs is an important step that needs to happen to kind of make sure that we don't arrive at a problem and then start creating a solution for it, because these are infrastructure projects. They do take more time to bring together.
Makes total sense. And from your point of view, Alessandra, I mean, barriers, you may have highlighted some, but what would you say is the main one for your technology to become more mainstream?
So again, I mean, so if you look from the LNG cold energy extraction perspective, if you look from that standpoint, at the moment, very few terminals have tried and deployed such kind of cold energy extraction systems, because many times terminals have not been designed for cold energy extraction, and actually they have been designed to provide availability and no hiccup or whatsoever, right? So the retrofit of heat exchangers to extract cold energy is something that is not obvious and then it be justified quite heavily. Whereas On the other side, we see that some of the new infrastructure, the new terminals, or also other form of energy storage, energy carriers, sorry, ammonia and others, there is an interest towards this topic, and there is a potential opportunity to integrate the cold energy extraction as part of the terminal or the bunkering storage site. Then on the adoption use case, I mean, to be honest, there is not so much on the policy or regulatory standpoint that is hindering the adoption of this cold thermal energy storage, but it's rather more on the end user side to be, familiarized with the solution and to believe that this can indeed support their operation and bring some savings. And at the end of the day, it's all about savings that they can see and tangibly see in the short, medium time. And maybe just to make a comment on the environment, the Southeast Asia market, I mean, some of the players we have been talking to, they are not very patient to the extent that they need to see the returns rather fast and to be quite robust and sustain over the years. So that's what we have seen from our side.
We have a few minutes left, but thank you for that, Alessandro. I maybe just want to continue to open up for questions, but one big question for all of us is, you're in this innovative technology space. You're needing sort of people to adopt. Do you see a role for governments, multilateral banks like ADB? How could others help you accelerate your technologies? There's something that could help us get people trying your technology or leveraging what you've learned more effectively. And that's an open question to all three of you. Anyone want to chip in on that?
Maybe very briefly from my side, I think we come in as an entity which was very much with development of new solution, new technologies, and we indeed try to bring this technology into the real field, right, for adoption and commercialization, right? And for some of the work that we do, the Southeast Asian market, and now it's not just only about cooling and refrigeration. I'm talking a broader scale to storage and maybe other generation of electricity and so on and so forth, grid management. We very much need a sort of catalyst or also an entity which has both the interest and also the muscles and the capacity to basically to foster the uptake and scaling up and the piloting of such kind of solution, especially in the Southeast Asia market, because sometimes accessing those markets is not obvious, especially if you sit in a region, in a country like Singapore, or maybe you also come from North America and Europe. So definitely I will see, hopefully in the future, a chance to work with ADB, to identify mechanism to unlock, this sort of at the moment. It's a broken link at the moment, or it's not existing link actually at the moment. And I think, that would be great from the ADB side. There could be support in that respect. Over to my colleague.
Yeah, if I could, go ahead, Eric.
No, you go ahead, Aaron.
All right. Yeah, I mean, just on one point each. So talking about the governments, I think some governments are already doing things about it. So it doesn't necessarily come from a business standpoint. It comes more from the end consumer standpoint. So you see initiatives like, in the Philippines where food security becomes really important and it's been sort of prioritized, or meals that are going out for school children in Indonesia. These are kind of initiatives that governments are already doing in order to push these kinds of initiatives, especially in the space where we're operating in the cold chain, because these are, frankly, at the end of the day, the goods are the most important things, and getting the goods to the necessary people are the most important things. So all of the infrastructure then that needs to be set up around that is, kind of what a lot of the governments can be doing and are actually doing to a certain extent. I think other governments in Asia can definitely step up and do more in that. In terms of multinationals or even, banks like ADB, I mean, I've been seeing thought leadership about this for some time now. I think maybe more visibility on this is definitely required on that part, because at the end of the day, I mean, and my fellow colleagues here will agree with me, it is an infrastructure thing at the end of the day. And so making sure that, banks are supporting a lot of these infrastructure problems and really investing into them would be sort of the next thing that we'd hope to see, especially in all these different kinds of regions in APAC.
Thanks for that. I know we've kind of gone over time, but any last words from you, Ari?
No, I think, I mean, just to kind of follow on to what Arvind said, it's that investment component. From our perspective, these are large infrastructure capital projects that need that support, especially with novel technologies that have limited deployments, but built on well established processes. And so there's that, and then, like I mentioned before, obviously the support in the procurements from the government level utilities, ISOs, TSOs as well.
Well, thank you so much, everyone. I know we've run over about a couple of minutes, but I wanted to first of all thank you all, Alessandro, Eric, Arvind, for sharing your innovative technology. Thank you for championing the energy transition with your technology. Thanks to ADB, obviously, for hosting this, for Cindy and her team. Thanks on behalf of me for everyone for joining and participating. Cindy, any last words from you? If not, we'll wrap up. I think we're good. So thanks, everyone. We're signing out now. Please keep on the energy charge. Please look into the technology and this whole area around cold energy. So thanks, everyone, for your time.
Thank you so much.
Bye, everyone.
Bye.
Thank you.